Wow, thank you, Pat, for that intro. So as Pat mentioned, we are from True Knowledge. So we're a full-service agency headquartered in Toronto, and we've been working in WordPress for the last 15 years. We've had the opportunity to work with some really great Canadian companies like Air Canada, RBC, Maple Leaf Foods, clients all over the world and in the US, including Edutopia.
Would you like to use it? It is on, is it?
It is on, yeah.
Hello, yeah.
I think it wasn't maybe close. I'll move it over just a little bit.
Sure. Okay, is that better? So for those not familiar about Edutopia, so Edutopia is part of the George Lucas Educational Foundation, founded in 1991 by filmmaker George Lucas. And the Edutopia website reaches millions of educators worldwide, focusing on articles, videos, research, resources, all focused on its mission of sharing what works in education. George Lucas says that education is the single most important endeavor of the human race. So this mission is deeply rooted into everything Edutopia does. So first, I want to talk a little about why personalization matters. So a recent survey from McKinsey showed that 71% of content consumers actually expect that their content is personalized, and 76% of users actually get frustrated when it isn't. So some really good examples that are doing personalization well, and some of the applications we might use every day. One being Netflix, which calls itself a subscription service that offers personalized recommendations to help you find shows, movies, games we think you might enjoy. So its recommendation system uses things like viewing history, ratings, how other members with similar interests are engaging with Netflix, and the metadata of the shows that you're watching, so genre, actors, categories, etc. And then it promotes those recommendations on rows like top picks for you. Because you watched X, you may like this. So not surprisingly, 80% of all of Netflix streams comes from those recommendations. And TikTok is another great example that does personalization first. So every interaction from sharing, liking, commenting on videos, watching, or even skipping videos, all kind of feeds their algorithm in real time and quickly, learns your patterns and pretty much curates an endlessly engaging feed that's truly unique to you. And most modern social platforms are moving towards this personalization first approach rather than who you're friends with or who you follow. So kind of coming back to Edutopia and a bit of where we started with them. So personalization has existed on Edutopia for quite some time. So when users create an account on the site, we ask them to fill out some information such as their grade level, educational role, subject matter expertise like arts, math, computer science. And as the user is navigating around the site, for example, on the home page that has a list of articles or videos, they'll see an orange check mark that indicates how the article or video matches their preferences. And additionally, on topic pages like social emotional learning, we have a Your Matches tab that essentially displays and organizes all the articles within that category based on those user preferences. In addition to the website, we'll extend kind of personalization to newsletters. So Edutopia has a weekly newsletter called The Intercom. So it's sent out every week. It's a collection of all the articles published within that last 7 days. But as we're processing each user who's going to receive the newsletter, we kind of compare each article with the user's preferences, and then we'll re-rank and move those articles to the top of the newsletter. And with this kind of change, Edutopia has noticed a huge increase in click-through rates from the newsletters to their site. So again, that's been on the site for a while, and with all of this in place and AI tools becoming more available, more accessible, Edutopia really wanted to see how it could help educators even more and evolve this technology. So they asked the question, what do educators need, and came up with a couple of key answers. So the first is educators want personalized content and resources that evolve with their interest and classroom needs. And they also want opportunities to engage with the community by sharing ideas, discussions, and feedback. So, teaching these days is incredibly difficult. Teachers often feel isolated, so having a trusted community where you kind of get help and support is really, really important to them. So Edutopia has about 1 million users in their database, many of which are, current teachers, former teachers, all willing to share their experiences with one another. So we developed something called the homeroom. So the homeroom delivers hyper-personalized recommendations to a user's feed. So these recommendations are not only based on the preferences like we did before, but now they're based on behaviors and interactions that users are taking on the site. So to kind of give a couple of examples of some of the recommendations a user might receive would be, whenever a new article is published, we compare it to the user's preferences and determine if it matches any of them. And if it does, we'll recommend that article to the user. If an article is receiving a high volume of comments, we'll recommend that to users to kind of join in the conversation. If an article is getting a boost in traffic, all of Edutopia's content is pretty much evergreen content. So an article published 6 months ago can still be relevant today, and it could be making its rounds on social media. And we have a stats service that helps power this kind of trending content. So if an article is getting a boost in traffic, the user will get recommended that trending article. We developed alongside the homeroom a section called Ask and Answer. So it allows educators to post questions and get feedback from their peers. So this kind of helped address the need of educators wanting to engage with the community more. So if a question is getting a lot of comments, it matches user preferences, it's starting to be trending, we'll recommend those questions to users as well. So we also have recommendations that are powered by AI. So for example, if a user views an article or saves an article, we'll recommend a similar article based on what they just viewed or saved. And if other users with similar interests are reading articles, we'll recommend that article to some of those users as well. So essentially, all these recommendations, and that was a few of the recommendations, we have quite a few more, but all those recommendation cards are fed into the user's homeroom, and essentially the more the users engage with the site, the more recommendations they'll ultimately receive. But our goal isn't just to kind of give users a bunch of recommendations. It's really about honing in on kind of what they care about, ensuring we're delivering the right recommendations to those users based on those preferences and their behaviors on the site. So I'm going to turn it over to Jeff, who's going to show us how this kind of works all under the hood.
Cool. All right, awesome. Thank you so much for the introduction, Anthony. Next we're going to be talking, this next portion of the talk is going to get a little bit more technical. However, we definitely want everyone here to feel involved, so I'm going to try and keep it as high level as possible. But the goal of this portion of the talk is essentially to show you what we ended up building for the Edutopia WordPress site, the technologies that we used, how we're using it, and hopefully it inspires you all with your website and how you can integrate it into your own WordPress site. So we're going to be talking about a few different things. As you can see, we're going to talk about how the homeroom leverages AI. We're also going to talk about how you can integrate the technology and the tools that we use into your own WordPress site. And then finally, we're going to go through a couple of examples. So I guess before we talk about the homeroom and how it leverages AI, we should kind of talk about the technology overall. And we've prototyped and shipped several different AI tools and features, and there's always one question that we ask ourselves, and it's, are we using the right AI model? And I don't mean are we using the right provider like OpenAI or Anthropic? I mean the type of model. All of us here are used to giving a model text and it outputs text, or with Nano Banana, you give it an image and a bit of text and it gives you an image, right? There's a bunch of different models. And I recommend checking out Hugging Face if you really want to go down that rabbit hole. It's a great resource for ML. But for our use case in particular, because we want to improve personalization, we ended up going with an embedding model. And this model in particular, it doesn't output text, it outputs vector embeddings. And that's the foundation of the Homeroom's AI feature. And to everyone here that isn't familiar with what a vector embedding is, it's a numerical representation of the content's semantic meaning. And I know that sounds very technical, and I said I was going to try and keep it as high level as possible. So we have this diagram over here, and you'll notice that there's a few different types of content. You could give this model an image, you could give it documents, you could give it audio. It's completely up to you. What's important is the context of the content you feed it. So you could see that we give this information to the embedding model, and then the embedding model outputs numbers. And these numbers, those are the vector embeddings. That's the numerical representation that I was talking about earlier. And you could think of these numbers as like coordinates on a map. And that's what's happening at the far left over there. You can see there's a bunch of different colored dots. Some dots are closer to one another. Some are further. The closer the dot is to it means it's more similar. And the further, the less similar the content is. So we're going to go into like another example, because this still might seem very technical to everyone. But we have 3 examples here. We're going to pretend they're all articles. We have an article about Apple the fruit. We have an article about bananas. And we have an article about Apple, the software company. And if you were to read this article, the content in it and the context behind all that is going to be very different between Apple the fruit and Apple, a software company, right? So even though it's the exact same word, they're very different. The content in the article is going to be very different. Whereas Apple the fruit and banana, they're both about fruits, so the information is going to be very similar. And that's essentially the power of the vector embeddings and getting the semantic meaning. So we're no longer dependent on keyword matches. We're able to determine what the context itself represents. And this embedding model, it captures many different things. It captures many nuances. So for example, on the Edutopia site, we might have a bunch of articles about math. Some of those articles might be about teaching math to elementary school students. Some of it might be for like advanced calculus for high school students. So even though we have so many articles about math, the embedding model, it captures the nuances. So if you're only interested in high school math, we're going to be able to determine that and only serve you high school math. Or if you are teaching a bunch of pre-K students, like addition and math and all that fun stuff, then you're going to get served this beginner level entry math content. And yeah, so that's essentially it. I'm sure you could already start to put the pieces together and see how we're going to use this technology to serve personalized content to all our users. And like Anthony mentioned earlier, this isn't necessarily new. This is like the technology that Netflix, TikTok, Facebook, and all these giant companies use to power their recommendation. So it's actually one of the older AI models. So it is 2025. Hopefully you don't have to train your own AI model. We didn't. We don't have to. When we were prototyping, we found that OpenAI had a good enough model. It was also very cost effective. So we ended up just sticking with that. We're also using Neo4j. So this is a database. This is what actually powers our recommendation engine. We'll go more detail into it shortly, but for now, the main thing that you just need to know is this is where we store the vector embeddings, like that map where all those dots are. We're able to do that like map coordinates within Neo4j. But again, we're going to go more into detail about how we leverage this as our recommendation engine. So now that everyone has a good idea of what vector embeddings are and how we could leverage it, I'm sure you already put this piece together in your head. We are going to start comparing articles by their semantic similarity. So previously, we needed users to actually go on the site and say, I'm a high school teacher, I'm interested in computer science, or I'm an instructional coach. And that's all great. Like, we were able to provide very valuable recommendations previously through the newsletter, like Anthony mentioned. However, now we have like a whole new way to provide these recommendations and see what's actually valuable to these users. So now that we are utilizing these vector embeddings, we are able to serve similar articles, not by like the categories they're defined, but by what the actual content in it represents. And additionally, we are now able to determine a user's interest through a collection of embeddings. So we're going to go through a couple examples of recommendations that we serve to our users. One of them, it is using like the article semantic meaning. However, we are going to talk about how we're able to determine what a user is interested in based on the content that they're seeing, utilizing these vector embeddings. Okay, so that was a lot. but hopefully we understand the technology under the hood. But again, I'm going to try and keep this as high level as possible. So we do have a bit of a data flow. And we have a lot of different pipelines that happen for all these different recommendations and just to keep this feature production ready. But we're going to talk about the most important one, and that's syncing the WordPress content with our recommendation engine. Because this is a WordPress conference, everyone here has a WordPress site, so I'm assuming you're going to want to use this with your site. So we're going to take a look at the very first step, and that's taking the content from WordPress. And this pipeline will execute in many different ways. Whenever the status of the post changes, this executes. So if it updates, if it gets drafted, deleted, published, whatever happens to it, this pipeline executes, but we're going to look at it through the perspective of an article getting published. So when an article gets published, we end up sending it to our AWS Lambda function. And it doesn't have to go to AWS, it could go wherever you want. You could even do this all within WordPress. However, the Edutopia site is a microservice architecture, so we have a lot of different things that we're connecting to, and we do that all through our AWS Lambda function. But end of the day, you could do this wherever you want. But what's important here is that we're processing the content from WordPress, we're formatting it, and making sure it's structured in a reliable and consistent way. So when we compare it to the other vector embeddings, it's actually taking the content itself and not necessarily being like, this article was 500 characters, whereas this one was 2,000 characters, right? Like now we're actually able to compare the content itself. And depending on your site, you might want to structure it a different way, but this is a very important step in order for us to use these vector embeddings to provide valuable recommendations. So once we've done that, we just feed it to our AI model. Again, OpenAI is our service provider. They have a pretty good embedding model. The cost is very low, and it's fast. So we give it to the model, and then now we are able to store it in Neo4j. And this is super important because now we are able to provide and serve these recommendations in real time. This database is in sync with our WordPress content, so if anything changed in there, if we got a new article, if maybe the author updated the article, all this content is going to be up to date. So this is great. We don't have to run this embedding model over and over again. We do it the one time, and we're good to go. So now that it's in our Neo4j database, we are able to serve it to our front end and provide some valuable recommendations. So a lot of you here are probably unsure about what Neo4j is. And I'm not surprised because all I said is we just store our vector embeddings in there. So we're going to talk a bit more about what Neo4j is. So this is a database designed to represent and query by nodes, relationships, and properties. And to anyone here that is technical, it probably just sounds like an SQL database. And you're not wrong, but there are some key differences. It's a flexible schema, so it supports dynamic and evolving data models. As your application grows and scales, you get new features, or maybe you want to change features. You don't have to worry about complying with a schema that was predefined. You can just add whatever metadata, whatever new key value pairs, so it's very flexible. We also have the high performance of connecting data. We're going to take a look deeper into this in a bit, but all you really need to know is that it's designed to handle large sets of data, like billions of nodes and relationships. It's going to query this information super effectively, so we could do these recommendations in real time. So for example, the Edutopia site has about 1 million users, but we're able to query the 1 million users in under 15 seconds. So the real bottleneck isn't even our database, it's like our AWS Lambda functions and our DynamoDB database that's hitting these rate limits. So it's very fast. As well as you are able to visualize and analyze data. So you're able to like audit it. We're gonna go into some examples. But yeah, it's very interesting to actually visualize the data and not just look at numbers or text. And finally, as you all know, it supports vector embeddings. So that is one of the main reasons that we want to use this. However, when we go into these examples, you're going to see exactly how this graph database can power a recommendation engine. Because that's originally what this technology was designed for. Okay, so everyone here has a WordPress site. It's a WordPress conference. So we're going to look at this through the perspective of like a typical WordPress site. So WordPress was originally designed to develop blogs. So in this particular scenario, we're going to assume your site has an article. And when there's an article, there is generally an author, right? So you could think of these two dots as the nodes in Neo4j. Like earlier I mentioned, there's nodes, there's relationships, and there's properties. And we could take advantage of all these things to essentially extract the information that we want. So we have some nodes, right? We have an article and we have an author. And in this particular situation, we know the author wrote this article, right? And your site is most likely going to have more than just this. Hopefully it also has users, right? And there's many different ways that users can interact with this article, right? Like they could save it, they could comment on it. In this particular case, they viewed it, right? And of course, your WordPress site has so many other things like the taxonomy, right? Like there are categories, and users might be interested in categories, or the article might be categorized under a specific category, right? And depending on your site, there's going to be more and more things like comments, right? And that comment will have other relationships. So as we're looking at this, like earlier I mentioned how this database is very efficient at traversing from node to node. It's essentially able to go from one node to another node to another node instantly, like very fast, right? So as your application grows and there's more nodes, more users, more comments, and more relationships, and as time goes on and more people start interacting with it, your graph is going to explode. There's going to be so much stuff. However, this database was designed to create these relationships, right? So you could already see that not only are we able to create relationships based on what a post is categorized under, but we're also able to determine how a user interacted with it and why they interacted with it. And we're now able to like just extract their behavior based on natural language, which is very powerful. Okay, so now that we got all the technical stuff out of the way, hopefully I didn't lose anyone. And now we're going to take a look at a few examples. So a moment ago, I just gave this example where we were looking at an article node and it had a bunch of like comments and relationships connected to it, right? It had an author. And this is essentially what we're looking at over here. This is that article node. You can see on the left, there's a legend. I was hoping the screen would be a little bit bigger. But if you look at the far left, you'll see that there's like an article count. Like there's one article, there's 92 comments, there's 76 users. And in this query in particular, what we wanted to do is we wanted to see all the people that have commented on it, all the people that have saved it, and we want to see like the author and the category associated to it. And because we're actually able to visualize this, we're able to extract very valuable information. Like one of the main goals for this feature was to increase user engagement. Previously, no one really commented on posts. However, we found an example of a post where a lot of people were commenting on it. And surprisingly, not just like commenting on the article, you'll notice that a bunch of these teal dots connect to other teal dots. So that doesn't mean that they're commenting on the post, it means they're commenting on other people's comments. So they're creating this user engagement. So this is like a perfect example of an article that we would want to reference and be like, okay, what did we do here so we can do the same thing in these other articles to try and reproduce this behavior. And to me, I'm pretty comfortable at looking at this, but don't worry, you could zoom in and you could also see what all these different relationships mean, who it's connected to, and so on. So the visual aspect of this is very powerful. This is just one example. This is one article. I'm sure you can all start to think about use cases for yourself. Again, the whole point of this conversation is so you can think about how you can use this technology in your own WordPress site. So because we're still talking about WordPress sites, I'm sure a bunch of you also have custom post types. And that's what we're taking a look at over here. We're actually using the exact same query that we used earlier where we found all the users that commented and saved the post. In this particular case, we're looking at a custom post type. It's a question. So even though the layout of this custom post type and the features on it are completely different, the way that users interact with it is the exact same. Like a user can save it, a user can comment on it, they could view it. So we could use the exact same query. And in this particular case, it looks very different because there's a bunch of different categories. So if we wanted, we could take a look at that, or we could like click on one of these nodes or one of these relationships, because earlier I mentioned we're able to query by node, relationships, and properties. So if you wanted, because like an article has a publish date, right? There's like a timestamp. You could take advantage of that, and you could use that to filter it down, for example. And we're going to take a look at that in a bit. But yeah, essentially, we are now able to extract whatever information we want. So maybe we wanted to get a better understanding of the categories that are associated to this post and the users that are interested in that category. Or maybe we just wanted to see all the people that are making comments on it. And we see like a bunch of people over here are making comments. We got some more people making comments. It's a video recording. I'm not actually doing anything. But yeah, I'm finding all these users. And I'm like, wow, okay, maybe I want to take a look into this, right? Like maybe I wanted to create a gamified experience. We want to like rack up points or maybe send them a thank you message. We could utilize this technology to see who's providing value within the community. So we just looked at an example of how you could do this with articles, but you could do it with whatever node you want, right? So previously we were looking at the article and all the comments and saved relationships that were created by all the users, whereas this time we're looking at the user and we're taking a look at all the comments that they've made and all the articles that they've saved. And as you can see in the recording, I zoom in. And to me, like, I'm pretty comfortable looking at this because I've been looking at this stuff for a while. But maybe you don't want to look at everything, right? Like maybe you don't care about saved relationships and all you care about are the comments that users made. You could filter it down and search for exactly what you want to find. So in this particular case, we're looking at all the comments, and just right off the bat looking at this, I could see that this user doesn't really like to start conversations. They like to reply to other people. Good or bad, I don't know. That's up to everyone, but they like to engage in conversations more than start conversations. Or maybe I just care about like the categories, right? And I want to see what they've been saving. I could see that they're a middle school teacher. I could see they're interested in math and computer science, but like they don't even save any math articles. They don't save any computer science stuff. They're more interested in middle school stuff. And this is like the whole reason that we wanted to get into vector embeddings and find another way to serve content that's going to be relevant to the user. Because they could have made this account 5 years ago. They might have changed jobs. They have new interests. So this is like a whole new way to determine what the user is actually interested in so we can provide valuable content. Okay, hopefully I didn't lose anyone yet. Now, all these examples that I've shown everyone, it's cool, but it's only valuable if you know what article to look for, or you know which user to look for. Again, Neo4j is like a very powerful graph database that allows you to enhance these recommendations. And because we have explicitly defined things like this person's a pre-K teacher, they're interested in computer science, we are able to take advantage of those things. So in this next example, we're finding the top 10 saved articles by pre-K teachers. So now we are able to find all the articles that this specific user group is interacting with using the explicitly defined values that we had previously. Like all this stuff I'm showing, we're not even using AI. This is just Neo4j, and this is like what it was designed to do. So let's say we choose one of these top 10 saved articles. We could find all the users that are pre-K teachers that haven't interacted with this. And then now we could serve it to them. So we know all these pre-K teachers love this. All these other pre-K teachers are most likely going to love these as well. And earlier I mentioned you could take advantage of properties as well. So in this next query, because when you publish a post, it does have a publish date, we are able to filter it down, right? So Edutopia has been around for 20 plus?
Probably more, yeah.
A long time. So even though the content is evergreen, so it's like content from 20 years ago should still be good today, maybe it's not as popular anymore. So we could filter it down to what was saved the most in the past year. And again, this is all so you can think about how you can use this in your own WordPress site. And hopefully the gears are turning and you're like, wow, okay, this could be a great way for me to serve this new content to users. So it's completely up to you. End of the day, as long as you're very strategic and mindful of the relationships that you're going to create around these nodes, the possibilities are kind of endless. Okay, so all these examples that we've shown, it's just Neo4j and the graph database. So we're going to take a look at a couple of the recommendations that we've actually implemented onto the Edutopia site. So here we are on the Edutopia site, and we're going to my homeroom. This has only been out for like 2 months. We're still cleaning it up. The UI will look better, I promise. But here is one of the recommendations that we're going to dive deeper into. You can see that it says, because you recently saved this article, we're now recommending this article. And many of you have probably already guessed, based on talking about vector embeddings earlier, we're going to use a semantic search to find similar content. So when a user comes to the Edutopia site, they're going to read an article, they're going to go through the entire site, and eventually they're going to find some content that they're interested in. So maybe this teacher, they're like, oh, I got a field trip coming up. They read this content, they're like, okay, I'm going to save this for later. I'm going to come back to this another time. When that happens, boom, like instantly, we have that recommendation generated for them. It was a UX decision to not make it appear in their feed immediately. We didn't want to distract the user from like new content. So when a user refreshes the page, they're going to see it, but the recommendation already happened, like within a millisecond of that saved content animation happening. So this is what it looks like in Neo4j. And you'll see that there are some titles on the left, and then there's some numbers on the right. And the number is the score. That's kind of telling you how similar this content is to the other content. And all of it's 80% and up. The previous article, I think it was like 4 strategies for field trips, and everything is about field trips over here. So clearly it's super useful. And so here we are, the user came back to the site because they wanted to learn some more, and there's a dot, sure enough. And then when they click on it and scroll down, they could see that they have this new recommendation provided for them. So again, the article they read was 4 strategies to maximize the field trip experience. And the article suggested to them is using the Montessori approach to field trips. I don't know about you, that sounds very similar. I don't know what the Montessori approach to field trips is, but I definitely want to read about it. And that's the experience that we're trying to provide to these users. So that was cool. Very, very basic, I guess, given the explanation that I've given so far. But I'm sure you could already think about how you could utilize Neo4j on top of that semantic search, right? Like previously we looked at these examples, and if we wanted, we could filter this even further, right? We could only get the articles that the user hasn't interacted with, or we could only get the articles that a person in their same user group is interacting with. So there's a lot of ways that we could choose to filter down the articles and then find similar content. So again, the possibilities are kind of endless. So we're going to take a look at another one. And this recommendation is a little more complicated. So again, I'm going to try and keep it as high level as possible. But when a user visits the site and it's a new day, they get several recommendations, and this is just one of them. An educator with similar interests read this article. And earlier I mentioned how because we are storing the vector embeddings, we are now able to determine what a user is interested in based on the content that they're actually viewing. So you have this user, they come on the site, And they start scrolling around. They're like, oh, this looks cool. We just caught that action. They're going to click on something else. We just caught that as well. And we keep seeing everything that they're interacting with. And this is all getting added into this one big collection. And we're like, this user was interested in that. They were interested in that. And they were interested in that. And then they got the recommendation. Okay, maybe this video wasn't supposed to happen. Okay, so essentially they interacted with this site, they clicked on things, and we caught a bunch of actions. And now we're going to look at what's happening behind the scene, like when they come back to the site for the very next day. So here's my account, and here's my vector embedding. You're going to see it's a ton of numbers. That's what the AI is outputting. There's no way we're going to understand that, but the AI model understands it. And that's like its superpower. But what ends up happening, I come to the site, we find who came to the site, and we're like, oh, okay, they came back. Let's grab their embeddings. And then it finds similar users, because every user that's doing things on our site, they all have their own collection of embeddings. And yeah, so over here on the left, we could see a bunch of user IDs that are similar to users. We could see how similar I am, like based on the score. We do have a lot of users, so even though you would think that there's a lot of different routes that someone could take, because of how many people are using the site, you're going to find some very similar users. So everyone's like 98%, it looks. And then we have the embedding count to show how many different pieces of content they've been interacting with. And that's just to make sure that the data is good. And yeah, so once we figure out who interacted with it, we find one of the users, and we figure out a similar article that they just interacted with. And boom, there it is, right? So again, we can decide, and then yeah, the person saves the article, so this just, it happens all over again, right? They save the article, they get a new recommendation, and it just keeps on going. And again, you could filter the recommendations however way you want, right? Like in the example I showed, we just grabbed the 5 most recently viewed articles, because when a user views the content, we store that timestamp in the relationship. So we could see how old these relationships are. But it's completely up to you. Like you are the decider of how you want to create these recommendations. So yeah, again, it was a lot of information. I'm so sorry. But hopefully you're all inspired now, and you have an idea of how you could use this technology to provide value to all your users. So we're going to talk about what we just covered. We talked about how you can analyze specific nodes and connections and like visualize it and extract information that you might want. You could filter by data points. So whether you want to filter by pre-K groups, right? Like you're a high school teacher, so you're in this group, or by filtering it down based on the date range to only find recent content. That's also possible. You could query by groups and clusters, like that pre-K example, or finding similar users. And you can essentially enhance the power of the already existing Neo4j graph database by adding the vector embeddings and creating a new way to serve relevant content to the users.
Cool.
Yeah,
Okay.
that's it. Hopefully you all like the demo.
Wow, very cool. We have 1 minute left, you said?
Well, we've got like
5 minutes, okay. Okay, so I'll breeze through kind of this boring bit. As Jeff mentioned, it's been 5 or so weeks since we launched the homeroom. We've already seen some pretty good metrics, a big increase in direct traffic site-wide, lots of visits to people's homeroom pages. 3,000 new accounts or so have been created in the first 5 weeks since we launched it. I think the most interesting stat is that some of these personalized cards have a click-through rate as high as 80%, which is significantly higher than any sort of click-through rate on any other card or article card or anything that we're recommending to users throughout the site. So that was a very kind of important number for us to say this is actually working. So yeah, kind of looking at what next and how we want to kind of evolve this technology a bit is really refine some of the recommendations gather feedback from educators. So as I mentioned, Edutopia has a very, very, very active and engaged community of teachers, former teachers. So their feedback is always invaluable to help us figure out what they like, dislike, and kind of refine as we go. We're also going to look at how we can incorporate richer data points. How long are people spending on articles? What are they searching for? What are they downloading? Which will then in turn, allow us to experiment with new card types and placements to really try and improve engagement further. And we really want to kind of scale this technology. So right now, a lot of these recommendations, they're all just living in with a user's home feed, but we want to pull those recommendations to other areas of the site, homepage, search, article pages, etc., and also bring these recommendations back into newsletters as well. We're considering how we can also reward power users, think gamification type stuff. So for the community that's really, providing a lot of answers to questions people post, commenting, how can we reward users for their behavior? So a couple of key takeaways we'll leave you with is, personalization does matter. Showing users what they care about really drives engagement and retention. And it's almost like obvious at this point. The best experiences like Netflix, TikTok, other social media platforms are personalized first. And really, this can happen across multiple channels. It doesn't have to be the web. It could be your newsletters. It could be a mobile app, et cetera. So really kind of taking this technology kind of anywhere.
Yeah, and from the AI side of everything, based on your use case, just make sure you're using the right AI model. Again, check out Hugging Face. It's a great resource for anything ML. Also, graph databases make relationships between users, content, and topics easy to map and query. You're able to create these relationships in natural language, like we saw earlier. And the AI model analyzes the behavior and patterns. So in the example that we showed, we used the vector embeddings to create the semantic vector embeddings. However, there are many ways that you could use AI models within the Neo4j database. You could even get an LLM to query data and then extract the information. That's like a way more advanced conversation, but I'm happy to talk to anyone about that.
And lastly, WordPress can do this too. We talked about Neo4j and a bunch of other stuff, but if you really break it down, if you have a WordPress site and you have users, and if you give users the ability to tell you what they're interested in, whether it's categories or taxonomies, you can use that information to serve recommendations. We do a lot of work with the Canadian Olympic Committee, and we built a digital fan club called the Canadian Olympic Club. So when users create accounts there, we ask them what their favorite athletes are, what are their favorite sports. And so whenever the COC publishes content that contains those athletes or sports, we'll recommend that to the user. And it's a pretty simple WP query. So nothing overly complex, but the recommendations happen. If you can capture behavioral signals like views, likes, comments, every interaction can really be a data point that drives and improves recommendations. There was a booth here yesterday called Accelerate by Human Made. I don't know if anyone checked it out, but it is a WordPress plugin. It uses kind of core Gutenberg, and they offer personalization just based on geolocation, UTM parameters, all that. So again, WordPress can do this too outside of what we showed. So we don't think we have any other time, so thank you so much.
Don't have time for questions.
It's all right.
Thank you very much.
We're here at the after party and stuff, so thank you so much.